Here's the problem. What's the best approach to managing all the various systems in your game? Consider the following scenario. I have a player class that houses some sort of functionality. Next, I want to add in a basic dialogue system, but I don't want the player to move while talking. A simple fix to this would just be to add a boolean check to stop the player from moving. This approach is fine, but it does not scale particularly well. For one, it can lead to a lot of dependencies in our player class, which can be a nightmare to debug. Secondly, trying to expand or remove features from this would more than likely lead to more errors. Consider the alternative. I have a basic scene called Overworld. In it, I have all my relevant systems for pathfinding, movement, etc. In another scene, I have a canvas that has some sort of menu. Unity is at its best when you're able to additively load and unload scenes, and defining the core modes of your game can be the first step to solving this problem. Abstracting out these modes into various scenes will allow us to dynamically load and unload specific systems with it, while state machines will give us a finer control over individual cases. So what do I mean by that? Let's look at the first part, how to handle the different modes of your game. You can consider modes to just be the overall flow your game may have. So in the current project, we know that there will most likely be 3 modes, an overworld mode, a menu mode, and an interior mode. The transitions between these modes will be handled by something called a stack. The stack will operate by having only the element at the top loaded. When a request is made to change, a new mode is pushed onto the top of the stack. The previous mode is loaded out and the new mode is loaded in. Then, when we wish to return, all we need to do is pop the current mode off the top of the stack and we will return back to the original one. Let's cover creating our main manager class to handle these modes, and then later on we'll create our state machine. I'm going to start by creating a basic singleton class. The game controller will probably be the only singleton in our project since I try to avoid them as much as possible, but I prefer to have a dedicated class to house the functionality anyway. Firstly, make sure that the class is put under your own namespace and that it is marked as abstract. This is more for good practice. More importantly, specifying the generic t value that gets passed through with the where statement will allow us to cast the object to our static instance. Without this, the compiler won't understand how to interpret the value passed through. Next, we will define an interface for our classes to inherit. It's going to be a fairly straightforward interface, a string to represent the name of the scene to load, and an enter and exit method. These will be called when we transition to our different modes. Now that we've done that, let's actually start creating our game modes. For now, I'm just going to make one mode. Start by creating a game controller script and an overworld game mode script. At the top, include the Unity engine.scene management namespace to allow us to access the scene manager to load and unload our scenes. Next, define an enum that will hold the names of your scenes. The reason I'm doing this is that it will allow us to avoid hard coding them. If you ever decide to change the name of your scene, rather than updating it in multiple locations, all you'll need to do is change the name of the enum. The game controller will consist of 3 core functions, 2 public functions to push and pop game modes, and a coroutine to change the modes. A coroutine is a Unity custom function that allows you to pause execution midway through it and return control back to Unity before, on the next frame, coming back to and resuming execution from where it left off. Here's how the transition happens. First, we check if the current game mode's count is greater than 0. This just eliminates the need to unload a scene right when we first start up, since we don't have any modes currently on the stack yet. Next, we check if the value being passed through is null. If it is not, then we can successfully push it onto the stack. If it is null, then we are trying to pop the current mode off the stack, so we call that instead. Finally, at the bottom, we load in the current mode, call its onEnter function, and wrap up the whole operation inside a boolean. To test it, in the start function, push the new overworld game mode onto the stack. Remember to double check that both scenes are in the build settings, then start your game without the overworld scene in the hierarchy. When you hit play, it should automatically load itself in. Now that we have it working for one mode, let's create a basic menu mode. Once again, make sure that the enum name matches the name of the scene and that the class inherits the iGameMode interface. In the game control update loop, I'm going to write a simple check to push and pop the menu scene on and off the stack. Thank you once again for watching. In the next video, we're going to start creating a state machine that will handle our player movement.